Hello everyone, and welcome to CodeSprout's Fundamentals of JavaScript tutorial series. In this tutorial, we will be covering variables and data types. Let's get started. In this video, we will be covering the following topics. What are variables? Declaring variables, variable naming rules, primitive data types, reference data types, and finally, we will be using variables to build an exponent calculator. So what are variables? A lot of times in programming, you will have values such as names and numbers change throughout the duration of your program. You may also not know what a value of a certain part of your code is until later on in the runtime of your program. This is when variables can come in handy. Variables are containers for storing data values. In JavaScript, a variable is a named storage location for data that can be accessed and modified throughout your program. Variables are fundamentals to programming because they allow us to store and retrieve data, manipulate values, pass information between different parts of a program, and keep track of changing information. At the top right, we can see some common variable types. We have strings that represent words like hello, hello world, and much more. Numbers which can represent values like 3, 3.234, and much more. We also have Boolean variables which can represent a true or false state. And there are also undefined variables, where we are defining a variable but are not necessarily attributing it with a value just yet. Declaring variables. We can add variables into our program through a process called variable declaration. In many programming languages, when we declare a variable in our code, we have to classify what type of variable it is. Is it a name, or is it a number, or is it something else? JavaScript is a dynamically typed language, meaning we can simply declare the variable name, and based on the value that we are assigning that variable, our compiler will automatically figure out if it's a text variable, number variable, or any other type of variable. We, t- we can declare variables through three main approaches: var, let, and const. For this tutorial, we will primarily be using the let declaration, which was introduced back in ES6 of 2015. And is now the preferred way to declare variables that will change. It has a block scope, which means it's only accessible within the block of code that it is declared in. An important thing to note regarding constant variables is that const variables represent the term constant, and declaring a const variable prevents reassignment, but not mutation. For objects and arrays, the properties or elements can still be changed, added, or removed. Variable naming rules. Variables are important elements of our program. And to understand what a block of code does, we need to be able to clearly identify what each of the variables are and their functions. This is why it is important that our variables are readable and follow certain rules that are generally recognizable by programmers. One such rule is the use of camel case convention. The camel case convention essentially means that every other word that follows a variable, such as in the term first name, we write out the word first and keep it lowercase, but then the second word, name, we'll capitalize the N to signify that there is another word in the variable. Variables cannot contain spaces, which is why camel case is an important and very readable naming convention. There are also certain reserved keywords in JavaScript, and naming a variable after one of these keywords will cause problems with compiling. That is because these keywords have specific tasks that the compiler will recognize them to do when mentioned. We will now go into primitive data types. Objects or methods may have multiple variables that are used to represent them. For example, with the car object, we may have a set of three variables to describe a car. The name of the car, which will be a string or text variable, the car mileage, which would be an integer or numeric value, and finally, if the car runs or not, which we can represent as a Boolean, true or false logic statement. There are other types of variables, such as undefined, null, symbol, and big int variables. But these three are the main variable types that we will be using. We will also be using undefined variables if we plan on assigning a value to a variable later on in our program and may not know the necessary value at the time of running. Certain certain primitive data types have certain methods which can come in very handy when writing programs, such as a string data type can convert text to uppercase or lowercase based on the method it's using. We can also figure out the length of a string or a word based on the length. Another important tip is using the type of operator when using the console to print statements. The type of operator will help us determine what type of value a variable is. Reference data types. In addition to primitives, JavaScript has reference data types, which are more complex data structures. The main reference types are objects, arrays, and functions. Objects are collections of primitive variables that can represent a more complex object, such as a car or characteristics of a person. As previously mentioned in our car example, we can have a car occupy three variables, which are mileage, if the car works or not, and the string or the name of the car. These can all be encompassed and packaged through a car object, which can represent all three of these variables and be defined based on these three defining parameters. We also have arrays, which you can think as a collection of numbers. Think of it as a book with each page flipping to a certain number that we have listed in the array. The page of the book represents the index, which starts from 0, and each value in each page of the book can vary drastically. We also have functions, which are blocks of code designed to perform a particular task. They are first-class objects in JavaScript, which means they can be stored in variables, passed as arguments, and returned from other functions. Unlike primitive values, reference types are mutable and are accessed by reference, not by value. When you assign a reference value to a variable, they're actually storing a reference to that value's location in memory, not the value itself. We will now begin implementing variables to create an exponent calculator. You can use any IDE of your choosing, or use CodeSprout's built-in playground to try out this exercise. Before we begin, I want to introduce prompts or inputs which allow the user to directly assign a value of their choosing to a variable within our program. We can do so by declaring our variable using the let keyword, followed by the variable name, which in this case, we will ask the user to give us an input for their username, so we can label this variable as username, which we can then set equaling to, and then using the prompt keyword followed by a set of parentheses. Within the prompt keyword, we can indicate what it is that the user is specifically being asked for. Since we are asking the user for his username, we can type in within the prompt statement, please enter a username. We can follow this by a console.log print statement and indicate the username that the user has picked. For a console.log message, we'll simply state, welcome to our exponent calculator program, followed by a comma, and then the name of the variable, which is username. If we run this, we're then asked in the input box to enter a username. For this example, we will use Mike. As you can see, our print statement now states, welcome to our exponent calculator program, Mike. We will be building on this further and implementing the prompt feature to get a value from the user that we will then use for our exponent calculation. To do so, we can start by declaring another variable using the let keyword, and this time we will name it exponent value using camel case convention. We can then set this equaling to prompt followed by a set of parentheses, and within the parentheses we can indicate what it is that we are asking the user for, which in this case we will simply type, please enter a value to find the exponent calculation. We'll then create a new variable called let, and then simply name it product, which we can then set as equaling to exponent value multiplied by exponent value. This product variable will essentially give us the exponent value of the user's input variable. We can go ahead and see this within our console.log print statement and simply state your calculation for the number followed by a comma, and then we will type in here the exponent value number so that it will return the input that the user initially gave to the program, followed by, and then another phrase is, and then we will use another comma, and now we will mention the product variable. So if we go ahead and run this program, we're first asked to enter a username. We will now use the username CodeSprout, but we can use any username of our choosing. Now we can enter a value to find the exponent calculation of. I'll use the value 15. As you can see, our console is now printing out, welcome to our exponent calculator program, CodeSprout. Your calculation for the number 15 is 225. We can go ahead and try this with even a different name, such as Mike with a ton of E's, and then an even more complicated number, such as 173. Running this program, we get welcome to our exponent calculator program, Mike with a lot of E's, and then it also gives us the calculation for our input number, which is 173, and the exponent calculation of that number is 29,929. Congratulations on completing CodeSprout's Variables and Data Types tutorial. You now know how to declare various variables, the different types of variables, and taking input from a user to define variables. We implore you to read through our lessons section and check your understanding through the lesson quiz. You can also continue practicing variable declarations in CodeSprout's built-in playground. In the next tutorial, we will be covering operators and expressions. See you then!